Everyone, this is Gary again, and today we're going to cover digesting drawings part 2. So in this video, we're going to talk about how to understand what you're looking at on the schematic or elementary drawing. So on the previous video, we talked about this being the positive rail and this being the negative rail. So what does that mean? In this case, it's 125 volts DC power. That means if I take a meter and I measure red lead on the meter to here and black lead, I'm going to read a potential of 125 volts DC. If I put my red lead on this point and my black lead on ground to ground, I'm going to read 67 positive. And from the negative rail to ground, I'm going to read negative 67. So the positive rail is all connected. It's one point. So all these dots here are connections to the positive rail. Does it matter where these connect to the positive rail? No, because the positive rail is where the positive voltage comes from. So you can connect this point here or here. It doesn't matter because electrically it's still going to work. That is key in understanding that this point doesn't have to be physically here. It could be here or here or here, and it's still going to work. Okay? Same thing with the negative rail. The negative potential here is exactly the same as it is here and here. So the negative side of the circuit can connect anywhere along the negative rail. Okay. Now we're going to get back into the numbers. Now we talked about on the previous video what some of these numbers meant, like 43, 63, and 52. So we'll cover some more numbers. 27. What is a 27? Well, let's look at our little table that we have here because we haven't memorized it yet, right? We'll go to 27, and 27 is under voltage relay. So that means this is an under voltage relay. That symbol is the coil. So that tells me that's the coil of the under voltage relay. Okay. Over here, what is this? This is a 51. 1. What is a 51 1? Well, the 51 is a IEEE number. So we'll come back over here. We'll look at 51. 51 says inverse time over current relay. That's a time over current relay, right? That's the coil for the relay, and that's the contact for the relay. Now we're starting to understand what all these numbers mean, and everything starts to slowly build up in your mind. So this becomes more and more clear as you progress through it. 86, what's an 86? Go back over here. 86 is lockout relay. So every time you see 86, you know it's a lockout relay. The T typically will represent, you have to look at another drawing or within the legend, but it will, in this case, the T represents a transformer. Now we're going to look at these contacts. You notice there's open contacts. And then there's closed contacts. So drawings show the circuit in a de-energized state. So that means in a de-energized state, the closed contacts are closed. The open contacts are open. Open contacts on a breaker are called A contacts. Closed contacts are called B contacts. That's why the 52B is normally closed. It's labeled 52B. That's a B contact. And the 52A is an A contact, which is an open contact. So when you look at these paths from positive down to negative, you'll see a series of opens and closes. And that's the logic that you have to follow to go from the positive rail to the negative rail. So basically all you're doing is you're starting at the positive rail and working your way down these devices until you get to the negative rail and talking this out in your mind. What are we doing here? What's happening as the electrons flow down this path? I use an analogy of water. If you've never done this before, water is a good analogy. Imagine this whole top rail, positive rail, is full of water. and the water's trying to get down to the negative rail. It can only flow where there's a path. If you follow this, we'll just start here. You use this real simple example of this green light. The G means green. My water's flowing down. It gets to this point. It goes through this B contact, which is closed. It goes all the way down to my negative rail. So as long as I have water flowing through there, or electrons, this will light up green. Green indicates the breaker is open. The 52B contact represents that the breaker is open, because on the breaker, when the breaker is open, the A contact is open, but the B contact is closed. The B contact is in the opposite state of the A contact. So when I look at this, I know this means breaker open. And when the breaker's open, you need to have a green light. That's basically how simple this process is. I just digested how this green light is supposed to operate. It is dependent upon this B contact on the breaker. All right, that wraps it up for part 2. On the next video, we'll continue.